Okay, so are you ready? Did you take your notes already? All right, so let's go over this one. And I kind of have the pages. I realized I had this page wrong. I wanted to include that first note set from today, but because I didn't include the 6 pages, I kind of have that wrong for your class. So anyway, measures of central tendency. This is 2 variable data, number 1. So you're moving out of exponents and into the next unit. You with me? That one had its lessons. Now you go through the lessons in this one. Follow it in the table of contents. And let's see if we can roll through this. There's four vocabulary words to discuss in this one. All of them you've heard before. Let's start with this. Mean. What's another word for the mean? Yeah. See? You have heard this before, right? Average, okay? Mean. Do you know the other one if I go down the list? Mean, median, and mode. Everybody say mean, median, and mode. Nice. A little bit of a tongue twister there, I guess, okay? So mean, then let's put median. Okay, good. Median, and where do I have mode over here? Let's put mode up here. And then at the end of it, we'll just talk about highest, lowest, / range. So if we put this right here, highest, lowest, / range. So this topic is, not really algebra. It's statistics. Are you with me? Why do they keep pushing statistics into the other math classes? Because it is actually very valuable to you. Maybe, and I'm afraid I'm on camera for this, but maybe more valuable than the algebra. Are you with me? The data is what you're dealing with all the time these days. If you think about what we're going through, why I'm even wearing a mask up here, right? It's all about a spread of a virus. Virus has so much more to do with data, and you see it on the news all the time. We're arguing over data, basically. Who's getting sick? Why? What does the data show? What can we learn from it? Right? So that's why we keep pushing these topics into your different math classes. I would highly recommend for you as you go through your math that you take a statistics course in high school. I think it's more important than the other math classes. So if they give you the option to go statistics, or you could get up to even an AP statistics, take that. Almost all of you in college will take a statistics class for that subject. I took statistics in engineering, for engineering. I took statistics in my business degree, for business. And I took statistics in my education degree, for education, right? All of it looking data specific to those topics. Are you with me? So I want to say it's important to you. And we kind of start you off with all these basics, which you've heard before, as illustrated with, you're just looking through them. You know these topics already. So let's kind of roll through them so you can remember what they are. Let's see what, and I want to try to use the examples from the notes. So let me try to, and maybe, Veery, if you can, if these are legible to you, you can read the examples to me. So let's start with, so this is find the mean of, what are those? 7, 2, 5, 10. So a data set, 4 numbers, and now it's a set, right? Imagine, though, the Earth we live on with 7 billion people, right? This data can be very large, right? And they call it large data because we're processing now with our computers all these different numbers, trying to figure out different things of what's going on with 7 billion people. It's pretty cool if you think about it, especially if you can come to the point where you understand sort of the data enough that you can pinpoint items where now you can communicate something with other people. You can say, hey, the data we think shows, right? And by the way, almost always we're saying we think, or looks like, or maybe. We're always hedging our bets because all these things never really say anything completely clearly, right? Sometimes when we go, it's clear. Rarely is it ever clear, okay? So let's start with average. Average is just add up the numbers and divide by the total numbers, right? So you're going to add all these up. 7 plus 2 plus 5 plus 10. Put them in a parentheses and divide them by 1, 2, 3, 4. Right? Is 24? Okay, nice. Thank you. Thank you so much. 24 over 6. And so the average for this is 4. And then as you get further into statistics, they'll start to look at the difference between the mean. So if the mean is 4, what are the difference between all the data points there? Because this describes a spread of data, right? Just because the average is at 4, one of the numbers could be super high and one could be super low, even negative, depending on what the data is, right? So this starts to tell you one idea of what's happening with the numbers, and it starts to try to paint a picture that we can then make conclusions potentially from. Okay, let's do the next one. Let me bring this down. Okay. All right, read the first median.
The number in the middle of the data set or the average of the two middle numbers.
Okay, so that's cool. Give me the data set. What's the numbers?
1, 1, 2, 4, 5, 7, 10, 15, 20.
Okay, did I get those? 1, 1, 2, 4, 5, 7, 10, 50, 20. Okay.
No,
So
15.
15, 20?
Yeah.
Sorry. All right, so the two things are, yes, the number in the middle of the data set or the average of the two numbers in the middle of the data set. So 15, 20. The nice part about this data set is, notice that we've already put it in order. What's the order to the data set? Low to high. We had a data point of 1, another one of 1, one of 2, 1 of 4, 1 of 5, 1 of 7, 1 of 10, 1 of 15, 1 of 20. And we put them in order from low to high. This allows us to count them 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I go 1, 2, 3, 4, and then I've got this one here, does that look like the center? Well, do I have 4 on this side, right? And do I have 4 on this side? So that is my median for this data set. Never will your data be arranged for you. You will have to arrange it, right? Your data comes in randomness type thing, the way we humans are, and then you're going to arrange it, and you're going to find that median value. Now, what happens if there's 2 median values? This is 9 data points, right? It's an odd number, so 1 pops out in the middle. What if it's an even number of data points? Okay, read me the next data set.
1, 1, 2, 4, 5, 6, 7, 10, 15, 20.
And I engineered this pretty well, right? So now you're up to 2, 4, 6, 8, 10. So there's an even number. There is no middle to this, right? So what we get to do is we get to go 1, 2, 3, 4. Let's exclude this half. And 1, 2, 3, 4, let's exclude this half so to speak. And now we're left with 2 right in the middle. So all we do is take the average. Right, and now you're back to this model, right? 2 plus 6 is 11, divided by 2 values. Divided by 2 is what, 5.5?
Yeah.
Okay, so now this is my median for this data set. Again, if you're dealing with a lot of data points, let's say it's millions of values, right? You are not going to do this without software to process this. And I don't know if Dr. Shi uses software in his statistics class, but that would be great if you can process larger chunks of data. Then you can kind of see what you would really be doing in the real world, so to speak. Okay, so that's median. Let's go to mode. All right. Okay, 2 examples from mode. All right, read the first data set to me.
1, 1, 2, 4, 5, 6, 7, 10, 15, 20.
And then check back over. I think I'm keeping up with you, but I'm not sure. I get a little behind. So what is mode? Mode is looking at the most often repeated value in the data set. Now again, this one is made very sterile for us, right? We wouldn't have numbers in this, so we would have to work harder to find what the mode is in most data. But in this one, it's all laid out for us, and I made these examples simple, right, so we can kind of roll through them quickly and simply. So in this data set, it's made clear to us, the only two values repeated are the 1 and the 1, right? So those are the two repeated, so the mode in this case is 1 for this data set, right? The one data point which repeats most often is 1. Let's do one more. Okay, read the next one.
1, 1, 2, 4, 5, 5, 5, 6, 7. One more 5.
One more 5. Look, I really went out of my way to make that clear, didn't I? That the 5 is the most repeating number, right? So the mode for this one is 5, right? Interestingly enough, I mean, we present these in such simple ways. We don't really have time to go into the statistics, but there's far more enjoyable things to do with statistics than just these basics. Sometimes I think we bore you a little too much with this, but that's what we're supposed to cover in geometry. So let's start with that. Let me see what else we've got. Let's talk about, lowest, highest, and range. All right, lowest, highest, range. Okay, read that data set, please.
60, 65, 65, 78, 60, 79, 62.
Did I get that right? I got lost track right here.
Okay, 60, 65, 65, 78.
Oh, 78.
60,
Huh?
79, and then 62.
Not nearly as good as I need to be. Okay, so 78. Tell me after 78.
60,
Okay.
79, 62.
Thank you so much. Thank you. Okay, so lowest and highest. And this is back to the idea here, right? If you're talking about a mean of 4 for this, we really want to know more about this data set. Just knowing that the average is 4 doesn't tell us very much. We're really curious how big the data set is, and we use this word range, right? Everybody say range. Right? How big is the range, right? From low to high. So lowest and highest value, the two in this case is, right? So you're searching through your data. This, again, not really in order. Look, there's a 60, so we're kind of going through going, what's the two? 60 and 79. Did I circle the correct ones? Now, so 79 is your highest value. 60 is your lowest. Notice that there's two values at 60, but that doesn't matter to us. That still is the low and the high between them. So our range for this is from 60 to 79, and they spell it out as highest value 79, lowest value 60, and range. Take the high, 79, minus the low, 60. The range of this is 19 data points, right? So back to just this idea of we know the mean of this one, right? The low is 2, the high is 10. 10 minus 2 is 8. So the range for this one just sort of an understanding in your brain of if this is the middle, how far does it go up to the upper part? How far does it go to the lower part, right? And that helps your brain kind of see. And you'll see all kinds of data sets depending on what you're studying, right? You could be studying certain types of characteristics of illness or disease, and you may have very flat data that runs across a very large range, and then it doesn't go much. You may have very compressed data that's all over the place, really big spreads between them, right? So this can be kind of exciting depending on what you're looking at. Okay, so quick on the vocab, let's see what's included in this. Mean, median, mode. Oh, good. One more. I'm glad I looked at this. So a very important concept we do get to cover at this point in this lesson is the idea of an outlier. And there's some good posters running around the room of, we'll see this in one of our future lessons. You know, it's describing, here's the data, here's a graph, and we have all this data. Each one of these is a data point. And as you look at the data, you as the observer, you're going, I kind of see something that happens a lot with human data. Human data starts to take a certain shape to the data. You're like, oh boy, there's a lot going on in the middle, then there's some things happening here, some things happening here. these become described as sort of tails of the graph, right? It's the tail ends of things where the data is shrinking off, and there's this mass going on in the middle, right? Then you'll have these situations where here's a data point. It's not really in the group, right? It doesn't make any sense. We're going to call that an outlier, and we're going to ignore it essentially. And so now you become the human sort of architect or engineer who's looking at the data going, is this something happening, right? Is there something going on that the data is showing me? Or is this just an outlier where that's the way it happens in human existence, right? So I'm going to ignore this. But this becomes the fascinating subject of the whole data set. What is this? What's the discussion around it? And this outlier concept becomes sort of the really fun part of, are we seeing something happening, or is it just something we're going to ignore? Okay, so outlier. Everybody say outlier. That's a really good concept, and even in your brain as you're thinking, oh, I see a lot going on, even if you're looking at things, right? We watch the news all the time, and you're thinking to yourself, that event, is that something outlier, or is this sort of the next thing coming down the road, right? Sort of a fun concept for you to keep in your mind. Okay, that's it.